Okay, Bismillahirrahmanirrahim. Assalamualaikum and good evening, ladies and gentlemen. I would like to welcome you all to webinar talk today, an innovative and sustainable road material to improve road surface performance while reducing plastic waste, plastic modified bitumen, PMB. Okay, I'm Zara Bizan bin Zakaria, will be your moderator along this session. It is my honor to be a moderator for this program. First of all, may I briefly introduce to you our guest speaker for today, Mr. Pon. Okay, Engineer Pon has over 15 years of experience in the design and construction of civil and structure engineering work. He is a registered professional engineer and hold a master of structural engineering and construction from University Putra Malaysia. His experience include major building, road work, geotechnical work, drainage, building inspection and maintenance work, oil and gas and building rehabilitation work. He started his career in Minconsops Sdn Bhd and involved in a few integrated development projects, including KL Central and PJ Central. In 2015, he joined Petronas as oil and gas civil and structure engineer in Group Technical Solution, we call it GTS, under the Civil Onshore Division. Moving forward, Petronas Sustainability Aspiration. Currently, he is now part of the Petronas Circular Economic team as well as the technical lead for the Asphalt Innovation Department. Ladies and gentlemen, please give a warm welcome to IR Pon to deliver his speech. Yeah.
Okay. Can you hear me?
Yeah, I can.
Yeah. Okay. Thanks. Thank you for the introductions and our moderator, Engineer Dr. Zara Bizan. I'm so happy to see you all here, and as I make known that today's session is full of participants. So yeah, I'm very glad and appreciate that. Okay. Good evening, everyone. I'm Punja. As I've been introduced by Dr. Zara. Okay, so I will be the speaker for today's IEM webinar. So I would like to thank you, IEM, to give us the opportunity to bring this platform up and for me to share with you on this what do you call it, sustainable road material. Okay, so as you can see on the screen, our topic today is actually an innovative and a sustainable road material, whereby we talk about sustainable every day right now, and to improve the road's surface performance, at the same time reduce plastic waste, which is the plastic modified bitumen. So my talk today is particularly relevant, very relevant to those who are the industry players with the related field, authority, developer, or even if you're an end user. So I have a lot to share today. So without further delay, let's start today's presentation. And about the Q&A sessions, I made known that today will not be any like verbal questions. There will be, you just type in your Q&A sessions. I will reply you at the end of the session. Okay, so next. Okay. So this is my structures of my presentation. So first, we will look into the Malaysia Sustainable Development Goal, SDG. After that, we'll look at the Malaysia plastic issue or the landscape, and then how we're going to use the plastic waste to recycle as the road material. And after that, I'll show you the project that I've done with this plastic modified bitumen and also asphalt, and also I'll show some result for you, and we will let you know some of the challenges that we face during the laying. Okay, so first of all, we look at the Malaysia Sustainable Goal. So as you know that the United Nations have launched this the 2030 agenda in 2015, focusing the sustainable development. So Malaysia, along with others, 192 UN member states, has expressed its commitment to support the implementation of SDG thus achieving set goals and targets. So there's actually 17 goals, as you can see here, and 169 targets and more than 200 indicators that cover 5 dimensions, namely people's planet, prosperity, peace, and also partnership. And the SDG will simulate actions over the next 15 years, areas where of the critical importance of humanity on the planet. So I touched a bit on the Petronas sustainable agenda as well. So the development of this waste plastic modified bitumen creates an opportunity for Petronas to employ our technologies and approach towards the economic activity. And not only is the environmental less harmful, but also preserving the resource, which is important in supporting our sustainable agenda that associated with net zero carbon emission through the repurposing existing material, besides implementing a good practice of waste management and recycle solution. So Petronas' effort in developing these modified bitumen from plastic waste is also aligned with the goal number 12. If you can see here, just now 17, we are aligning number 12 under the nation, under the UN SDG, so which is to ensure that the sustainable consumption and production patterns. Under Goal 12, some of the mentioned targets are to sustainably reduce the waste generated through the prevention, reductions, and recycling and reuse by 2030. So, to encourage company, especially large and transnational company, to adopt practices and to integrate sustainable into their reporting cycle. So by the way, Petronas also actually reporting annually on all these activities. Okay, now we jump into the Malaysia plastic landscape. So so just now I mentioned about the 12. So now we focus on the 12, which is the responsible consumption and productions. So how well we are doing in terms of recycling. So as you can see that tonnage of material recycled, that tonnage of material recycled is including plastic, aluminium, paper, glass, steel, and battery, and other thing that is recyclable. So we can see that it's actually million tons of waste can be recycled every year. So, and the trend is actually increasing, and 2019 is 28.1 up to 2021, which is the 31.5%. So, and all these things has been keep on tracking, just that 2022 is not being reported. That's why my data is stopped at 2021. Okay, so what is actually has been recycled all these years? So next is actually we look at the this table, which is showing that what kind of material has been recycled throughout these few years. So of course you can see there's actually plastic waste, aluminiums every years, and also glass, steel, battery, and also others. So our focus now is actually at the plastic. As you can see, plastic is surprisingly from 1.5 million after that jack up to 2.7 and drop down to 1. I believe it's actually 2020 is because of the pandemic. It used a lot of plastic, all these things. And in 2021, it reduced back. So yeah, a lot of people will say 2020 is actually not appearing. So fine. So let's look into the plastic one. Okay, so I will be focusing on these 4 plastic resins, which is PET, HDPE, and LDP and PP, which is actually these 4 major resin, I would say plastic resin is actually being recycled the most and frequently being recycled. The rest, most of it is actually to be what do you call it? Less chances of recycle, I would say, because there's actually 1 to 7 types of plastic here. I'm focusing on 4. So as you can see, the number 1 is PET, then number 2 HDPE, LDP, and PP. So I just highlight the importance or the highlight of all these plastic. So one of it is actually PET. They have good thermal properties. So another HDPE is actually stiff material, as you know. Most of it is actually the food container, milk juice bottle, all these things. By the way, PET, most of it is actually our mineral water bottle. The body is actually PET. So high density HDPE is actually those food container, milk or juice beverage container, which is actually you can see quite thick and quite hard. Yeah, and also less transparent. So another one which is very frequently seen in the market, which is LDPE. So it's actually a thin film like material, and it's actually very high strain, I would say. It can actually very high elasticity. Yeah. So not elasticity, plastic. Okay. So after that, most of it you can see in plastic bag. Those even water tank also actually sometimes you see LDP, which is very thick actually. So after that, the next one is actually PP. So PP is actually another material whereby used a lot in doing all these container. Maybe if you're the one that you heard a lot is Tupperware. Another one is actually the bottle cap. So in fact, in one bottles of mineral water, it's actually combinations of few types of plastic. The same goes to all types of plastic. So there's actually combinations of the plastic. So that's why when you are really go into this kind of business, you start to know, okay, then you need to separate it. So before you throw it, all this thing. Okay. So next we look at how Malaysia plastic produce and what is the usage. This one is actually this one in the survey is actually at 2019. So you can see that the two plastic, which is PET, is actually the they have these what they call it, plastic packaging, and also PET packaging, and also PET polyester, and also next one is PP, HDPE, and also LDPE. That's why we are focusing on these four, because most of the time these four will generate most of the income of the Malaysia. So you can see that they are actually all in tons, is in tons, which is 70 100 tons, 70,000 tons. So the green color is actually local productions, and also the blue color is local consumptions. Okay, so the next one, where does it use for? So you can see that most of the plastic is actually used for packaging, which is 48% of it. So the second one is actually electrical and electronic, and most of it, if you notice that this 27% is the PP plastic. Okay, so after that, the rest is actually automotive, constructions, households, agriculture, and others. So this is the one that we use in 2019. Okay, next. So how is the plastic waste generations in Malaysia? Do you notice that actually we ourselves, every one of us, generate 0.85 to 1.5 kg per person per day, and the 0.14 to 0.37 MT, this is not metric ton, it's actually million ton. So plastic waste leak into the oceans, so we call it marine waste. So it's actually quite serious. And also you know that it's actually in the estimated 2050, plastic is more than a marine life. So this is actually quite serious. So after that, we can look at the post-consumer plastic waste generations, which is the one that after we use mostly is on individual. So in 2016, from 1.07 metric ton increased to 1.4 metric ton to 2019, and this problem is keep on increasing. So where does all this plastic gone? Okay, so here you can see that there is actually a roadmap, I would say, the material flow from how after they produce, after they finish use, become waste, and where does it go? So you can see that in 1.67 metric tons of plastic into the market, and actually 1.4 million ton, sorry, not metric ton, million ton is being disposed. So only 0.23 million ton, which is also 24% being recycled. So the rest is like 10% being put inside the landfill, which is sanitary landfill, and also 3% put in as an energy recovery. But unfortunately, 63% of it, which is 0.9, almost 0.9 million ton, is being not being recycled properly or not being disposed properly. 66% of it is actually disposed in an unsanitary landfill, and the rest is actually open burn, leak into the sea, and leak into the floor. So you can see that this is how serious this is all about Malaysia. So this is how serious about plastic pollutions in Malaysia. And if you notice that the 24% is actually far away from our target in 2025, which is 40%. So now we are only in 2019, we are only recycling 24% of plastic. So it's actually quite far apart. So and you know that in this, apart from this 24%, all this plastic which is not being recycled have cost us lost about 1.07 million tons per years of the value, the million tons of the plastic value leak, and we cannot be recovered. Okay, so as you and you can further see that all these things is actually about the 4 main reasons, which is the PET, HDP, LDP, and also BP. Okay. So next, we look at this value thing. Okay. So what is CFR? CFR is actually the collected for the recycling rates. So they have done a study in 2019, whereby how many plastic has been recovered. So in of course you can see PET and PET is actually the recovered the most, because this is the easiest to be recycled and also to be collected. And then second will be PP. Then after that, you subsequently follow with HDP and also LDPE. So you can see that all these resin that in Malaysia covered in this study are to be recycled into the most valuable recycled product. So if let's say we are able to recycle all this plastic that we have used, which is 1.4 just now million ton, actually we can generate about USD 1.3 billion per year. But because of only 24% being recycled, so you can imagine that how many millions that we have lost. Okay. So so this has resulted that every year we have already lost about 1 to 1.1 billion because of the we never reuse or recycle the plastic. So when we talk about recycle and reuse the plastic, we definitely, I think definitely we heard this kind of terms. We call it as a new plastic economy. So which means that we turn whatever the plastic waste into something which is usable. So this will be my next slide. Okay, so you can look at it and say, what if the plastic can be used, that can be used and reused again and channel back into the value chain infinitely. So definitely, that's why I mentioned, this is what I mentioned earlier, that USD 1 to 1.1 billion dollars will be generated from the waste plastic. So so we have to change our mindset from plastic as a waste to plastic as a resource. So of course, this is one of the Petronas PCG new plastic economy way of changing it by educations, cleanup, infrastructure, and also innovation. So one of the major breakthrough that we have is actually to reduce the plastic into the bitumen. But the question would be how? And also how will it affect the bitumens and also the road? Okay. So that's bring me to the next topic, which is the plastic waste and also recycle as a material road. So now we talk about roads, the plastic part already covered on these how it's actually being wasted, all these things. But when it comes to road, we have a lot of issue as well. So as we are all road user and every day, especially engineers and also authorities, you need to travel a lot. And most of the time you will be feel angry or irritated by all the road conditions. And all these road condition, it come we have compiled into the few factors. So this is all the pain point that we have identified during our study. There are actually high traffic load and heavier vehicle that exceeds the design intent. It's not saying that we purposely design lower or we are not there, but just that sometimes the traffic is very high, or maybe more than the growth rate, or maybe some illegal vehicles using the road, so that we definitely exceed the design intent. So the next thing is that kind of intensity of using the road or heavier vehicle on the road definitely will reduce the life cycle of the road. So that is actually a direct proportional of the heavier load to the lifespan. And after that, of course, lack of maintenance, because you have a shorter lifespan and you didn't expect to be spoiled that fast and made that fast, then it's actually out of your maintenance program. That's why normally you see a lot of potholes or road damages. due to the lack of maintenance. After that, there will be low softening point as well because of the properties of the bitumen and due to the extreme weather. And if you notice that because of this what they call it, climate change issue, and you feel that the climate has been changed a lot since I think last 10 or 20 decades the years, then definitely the melting point is actually getting, now the temperature is getting higher. So last but not the least, which is the groundwater and also the flood issue. All these things you can see propagation in social media as well. I can, if you notice, there's actually some voluntary people to patch up the hole, and sometimes the authorities also have no ideas how to because of these segregations of the boundary of the road, who's supposed to be maintaining the road, all these things. So a lot of image issue, I would say. Okay, so this is where the plastic modified bitumen come in as the solutions. So what is the solutions? So of course, the whatever bitumens or premium alphas that's being introduced, the safety is the priority, and also not saying that only safety. We also looking into the comfort and also sustainable. So the idea is actually to add in the recycled content inside the bitumen. So it's a secondly, you also adopt a sustainable specialty mix and that fits perfectly into global sustainable trend. And of course, the modified bitumens or modified binder will offer the following benefit, which is resistant to rutting, fatigue cracks, crack due to binder hardening, and also to improve the adhesions of the binder to aggregate. So this is what normally the premium binder can be offered. Okay, so next, what is the goal of the plastic modified bitumen? It is to increase the quality of the road, the safety, and the comfort of the user. So safety, of course, is the topmost important thing that we need to be taken care, because if you have a low quality road, then of course you have a lot of issue like a pothole, and you know that pothole actually kills people. So this is the one that we don't want it to be happen. And secondly, of course, you will see a lot of uneven surface and cause a lot of issues on the car, all these things. So that will be actually linked into the second one, which is the comfort. So of course, the more I would say, the more flatter or the more even of the road, so you have a more comfort ride. So imagine that you have a nice car, but then the road, like I heard one at one point, there's actually a person told me what they call it, the road on the moon, something like that. So definitely you don't feel it's comfortable if let's say you're driving on it. So of course the next one will be the one that will disturb you a lot, is actually the noise generated. So of course the BMB is able to reduce noise generations in between the tire and also road surface. So thirdly, of course, all these products that we are doing right now is actually sustainable, which is supporting the aspirations of net carbon zero emission by 2050 and in line with the agenda of 2030 and green technology. Okay. So next will be the benefits. So we talk about the benefits of, if let's say using this kind of premium modified bitumen. So of course the lifespan is conservatively can be extended minimum of 25%, and also that will reduce, of course, the OPEX operation cost, which is the reduce the maintenance schedule. So of course that is for the authority or developer. Okay, for the road user, of course, you have a safety and comfort, right? And also the reduced noise. For automotive industry, so it will be better, perform better in various weather conditions, and also it improve the lifespan of your tires and reduce the vehicle maintenance costs, because all these vibrations and also to minimize the fuel, to reduce driver fatigue is very, very important. If you have a great road or the good one. Okay, so after that, we will also look into environment, the benefit environment, whereby if let's say most of the road we use the plastic waste to lay the road. We can reduce up to 16% of the plastic pollution in Malaysia. At least you can see in reducing the landfill, because most of the plastic at the end of the day is actually being landfill, which is actually using up the earth resources, all these things, and space, which is definitely not a sustainable solution. So what we're trying to do now is to actually use all this plastic, and as much as possible, we need to reduce the landfill. And do you know that every 100-meter lay, the road, so the 100-meter lay, of course, we're talking about one lane, of the road. So it will be utilizing approximately 80 kg of the plastic waste. It's actually quite a lot. So imagine if you have a 1 km road, so you can reduce 800 kg. If you have 10 km, 8 ton. And if let's say times 4 lane or 6 lane, then we even more. Okay, so next will be the road concessionaire. So you'll be wondering, if let's say the road is so good, then the job will be lesser. So in fact, the plastic modified bitumen are able to blend in all the existing facility without much alterations or modifications of the existing facility. So of course, engaging the industry player to contribute towards the sustainable agenda. Okay. So next, we have done all this benefit and how does it contribute back to the societies and also the environment. So the next one will be the interesting one, and how does it being planned. Okay, so this is the plastic modified road, plastic waste road to the plastic road. So how does it be being implemented in the road and the end product? So you can see here, of course, we started with the waste plastic and also raw bitumen. The raw bitumen can in Malaysia is 60, 70 right now. And then after that, the plastic is shredded, and then we put it inside this what do you call it, bitumen blending facility. Then the output will be the modified binder. Then after that, we send to the premix plant and then aggregate. Then the end product will be can be laid on the road. We call it as actually it's a plastic road lah. So you can see that this is all the plastic waste that we are using. Then we need to be, of course, you need to have a collection center, and also you need to be sorted out so that you don't need so many because the rubbish that collected is actually full of dirt and also full of contamination. So you don't want this contamination or contaminated material to reduce your bitumen property. That's why you definitely need to segregate it, and you also need to clean it. So after that, after the segregation done, you need to shred it into this kind of what they call it is a plastic flake. So this kind of plastic flake, of course, you need to be dry out everything, because bitumen is quite sensitive to water and moisture. So you have to dry it up, and also you mix it inside the bitumen and blend it together. So of course, you see all those various colors of plastic will be added in, but at the end of the day, still black color. It won't be have different color. Of course, if you say you want something different, you want colorful one, no problem. It can be done. But then at the end of the day, the most important thing is actually the bitumen is performing in a more better or premium in a premium way. So next, after we blend it, so of course we show you the picture how we blend it. Of course, we already use it to lay in our road. I'll show you one of the few of the project that we have done for this plastic modified bitumen. Okay, so the first one is actually, this is doing MCO. So MCO is actually quite a tough job for us. So to lay this thing in our, of course we need to lay in our own permits first, because of the authority issue. So this is one of the lay in pre-ISP in Bangi. So we lay it, and you can see that this portion of road, which is the black color one, which is mainly using the plastic modified bitumen mixture, okay, with the asphalt. So all the process is the same. You can see premix plant. After that, we do quality check. Then it's actually inside become this asphalt. Then after that, lay on the road. Everything is the same. Just that whatever we do is actually mixed with all this waste plastic. So surprisingly, until now, you can see all this whatever you see now in the picture, which is black color, and until now it still maintain the same color. So which means that the binder is still very intact with the aggregate, and so that the color will still maintaining lah. So this is what we find out until now. So it's about how many years? 1.5 years now from now. So the next one that we have done is actually which is we expand our laying into a federal road. Of course, this one we have already get JKR, what do you call it, collaborate with JKR to lay at the federal road, which is at the FT 185 Jalan Simpang Pulai Longjing lah. So this road later on I will let you know further on the details. But you can see that all this process that we have come through from the internal lay up to the external lay, and all is using the same material, which is a plastic modified bitumen. So and we are quite happy on the result that we will show you later on. Okay, so yeah, let's move on this. So I'll be focusing on this federal road laying, because the internal one you will say because lack of traffic, it cannot be a showcase, all this thing, right? So we make this as the main someone talking. Okay. So just a reminder. So please mute your mic. Okay. Thank you for your cooperation. Next, we move on to this lay. Okay. This project, which is the laying at this FT 185. So next is the location. This laying is actually at the somewhere around in between Perak, Kelantan, and also Pahang, because the road is actually crossing these three states. So if you zoom in, it's actually here. You can see it's actually crossing these three states. So the place that we are laying is actually somewhere around here, which is, if you can see, if you want to look it in the map, it's actually in front of Masjid Lodging. So so the next one will be this. Okay, so this is actually the exact locations where we do our laying. So the road length is about 47.2 km. Of course, that's why he's actually crossing from Perak until Pahang and also Kelantan. And the nearby landmark is actually Masjid Lodging. So this is the details of the tri sections and also the control sections. Okay. So these tri sections, the green color one is the okay. Okay. So this green sections is the 200-meter with the PMB. Okay, so this PMB, the details we are using SMI20, and the blue color is actually the control area, which is requested and also by JKR authority to have these control sections for monitoring purposes. But is using AC 1460/70, and the pave length is actually 200, and the 200 against 150. Supposed to be 200 because up to corner level, so which is not a fair comparison. That's why we don't proceed, and we shorten it. And also the pave length is pave width is actually the full width. This is actually shown in the red color, which is the full width of the road. So total length is about 350 meter lah. And some of you might be asking, let's say it so happened that you want to do a comparison, why not you use AC14 premium mix, which is the AC14 with modified bitumen against the AC14 with the standard bitumen. So the reason behind is actually we want to test our bitumen technology. Okay, so it's very important that to note that we have done the initial or assessment before the laying, and we found out SC14 is unable, to be frank, is unable to resist the high loadings and also high traffic. So in order for us to test the technology, it definitely has to be a better or premium asphalt, which is SMI20. So later on, I will show you what is the existing condition of the road, and that's why we have decided to go for SMI20 with the PMB, which is the plastic modified bitumen. Okay, next. Next I will show you the material testing and the result. Okay, So of course, what kind of specification that we are referring, of course, for SMA 20, and we are referring to JKR, and also the fiber pellet also, because of SMA, you need to use fiber pellet fiber. And of course, so far we are referring to the polymer modified binder, because one of the requirements in JKR that you want to achieve, you want to mix with SMA, is to use performance grade of 76. So this performance grade of 76 is definitely the what do you call it, the polymer modified binders, the only binder that's stated in the what do you call it, 2008 S4 specification lah. So that's why our PMB also, actually we are referring to this plastic modified binder spec. Of course, later on there will be a specification specific to this plastic modified binder. So so in this polymer modified binder, they are targeting PG76. That's why, as you can see here, the dynamics here, they are tested to a 76 degree, which is also the PMB, the plastic modified binder, we also tested to this 76. So to qualify that, this bitumen is able to achieve this grade, PG76. So next, I will let you see some of the what is the test that we have conducted for this modified bitumen and asphalt. So and also this kind of test is also one of the requirements that the JKR imposed to us, that they need to see this result before they get approval. So to be frank, I'm showing all this result to you. Is most of it is already submitted to JKR. Okay. And plastic modified, of course, you test all these properties, including the dynamic shear of unaged and also short-term aging, RTFO. And also the compacted mass, we have you. This is all the normal tests, and also they have asked for the residue modulus, dynamic creep, Pantapro, semicircular band, and also wheel tracking test. And of course, the core sample will be tested to density and also the layer thickness. Okay. So all this photo, this is the, if you can see that this picture particularly is actually the PNB. It doesn't look any difference from other bitumen, to be frank. So this is the Marshall sample, like from the loose sample, and this is all the core sample from the road. Okay. So I unfortunately, some of the result I'm not so convenient to share it here. But of course, if you have any more further detail, you can contact to me. Okay, so I'll tell you on this requirement of the PMB. We are actually achieving the requirement of polymer modified bitumen. That's why in our test as well, we also get the normal or conventional PG76 to be tested against the this requirement, and also we compare to the PMB, plastic modified bitumen. So whatever the test that we have conducted is able to achieve PG76 easily. So just it's worth to note that 60-70 is actually the penetration rate, but and you come to a higher what do you call it, a better binders, normally you call it PG76. In fact, if you convert into a binder grade, it's actually a PG64, which is actually if you remember just now I mentioned about 76 degree here. So for binder grade 64, they will be put it back to 64 degree, so that you can achieve minimum 1 kPa for the dynamic shear. Mostly for the routing purpose, this one. Okay, so all the tests that we have conducted is actually complying, and also we are is actually comparable to PG76. So this PG76 at this the one that we have tested is actually using the virgin plastic, which is the SPS. So ours one is using the modified, no, sorry, it's the grease plastic. Okay. So next, this is the volumetric properties of SMA with the PMB. So of course, there is actually a requirements spec that we have referred to the JKR spec, and most of the time they actually for JKR they look at the VTM, VMA, stability, flow, and stiffness. So this is all the spec or minimum requirement that we need to achieve, and you look at quarry and also test lab means. The quarry that we are doing this plant trial, and also before we send it to site, and also with the result is obtained from there. And the testing lab means after the trial or the laying. So all these those sample will be collected and send it to lab for another test just to confirm on the qualities of the mix. So you can see that from the quality is actually achieving stability of 7,000, almost 8,000. But whereas in lab is achieving about 13,000 kilonewton, 13,000 Newton. Okay, so the flow is actually within the range 2.7, which is lower compared to the quarry one. And of course, with all these the numbers, the stiffness is able to achieve more than 2,000 Newton per mm. So this has proven that the SMA 20 with PMB is not only able to achieve the JKR spec, it's actually surpassed a lot from the JKR spec. Okay, so all this result is not a single sample, it's actually an average value of all the samples that we have tested. Okay. Next will be the rest of the compacted mix test that we have carried out for the according to the JKR requirement. So the binder drain down, of course, for SMA is a very important parameters to be determined, and it's worth to note that the maximum is actually 0.3%, and we achieve way lower than that, 0.06%. The next one, which is for me personally, is very important parameters, which is the residual modulus. In fact, in JKR spec, they don't really require to check for the residual modulus. But for me, in residual modulus is a very important figure that so that you know that the recoveries of the pavement after being loaded. So that is actually your capacity of your strength of your pavement is mostly depends on this modulus result. So you can see that minimum is 2500 megapascal. So if you look at the spec, right, it's not being stated in the SMA spec. It's actually stated in the NC14 premium mix. So this is where I get the 2,500. So if you look at the test has been carried out at the lab, and all of it is actually double of the residual modulus of this minimum requirement. So next is actually the dynamic creep, Cantapro test, semicircular band, Hamburg wheel tracking result. Okay, so the dynamic creep, if you can see, the result is actually 58.3. Okay, so the 58.3, 55.5, and about 50. So what the dynamic creep can tell you is actually after the what do you call it, the frequency of loading on it. So what is the strength that from all this loading? So the is actually yeah, this is the value. And also for Cantapro test, which means it's actually after the mix, they will actually put inside a drum to roll it. Then after that, see is there any how many mass loss after the test. So the mass loss have to be less than 15%. So what we have, what we get the result is actually even lower than about 6%, which means that the binder adhesions, the binder and also the aggregate adhesion is very high and very good. So that's why the losses is actually way lower and then more than half of the requirement. And of course, the next one is actually the semicircular band test, which is you literally cut your sample into half and you test it. And also the next one is actually the wheel tracking test. So in this wheel tracking test is actually we do it in two percentage of void. One is 7%, another one is actually 4%. So that's actually a reason behind doing this test, because 7% void is usually do it for underwater conditions or moisture conditions so that you have space. But then for normal circumstances, if you it should be under 4%. But then we test it under 4%. The result is actually very excellent, 1.55, or even 7% void also you can get 3.87, x6, which is way lower than 12.5, which is the requirement. Okay, so this is all the result that show. So shown that the behavior of the binders with the aggregate is actually very excellent, I would say. Okay, so next, of course, this is another requirement for the core sample, whereby we need to core the sample and also test it for the thickness and also density of compactions. The density and also compactions. And you notice that some of the thickness, yes, is low, um, but you have to be aware that when you're cutting the sample, because sometimes you have to really look at the sample. Why is it less than the required thickness, which is now you can see some of them is actually 36.9, 38, and 34, 35. So all this is, to be frank, is actually not qualified. But you have to look at the sample itself, the core log, and you have to look at it and see. This is a problem that we have faced on the test lab, because after they core, when they trim the time, they have mixed with the binder cost. So when you mix with binder cost, of course, the binder cost will be way thicker and your wearing cost will be way lower. This is what happened, and this is what we have noticed in the test in the lab test. So this is one of the item that you definitely need to take care when you're doing the road test. But having said that, all these bulk density also compaction is actually I would say pass. Okay, so if you look at the what is slow lane, fast lane, if you look at this I would say draft say sketches. Okay, the sketches is actually because the road is actually 2 lane with one deceleration lane. So we put it as a fast lane. Of course, the most right lane, and the left lane is actually slow lane. Of course, the most left one is actually the decelerant lane. So this is the number of core that we have done. And of course, for AC14 as a control area, we also need to be tested. Of course, this result is not going to be shown because my focus will be in SMA. So this is all the photo that they have taken. This is we have taken 24 hours after the lake. So you can see that the road is not have not been put in any what do you call it, the road marking yet. Okay. So okay, so of course all from the what I have presented just now is all about this the performance and the mixtures and how does it whether you can achieve the checky aspect or not. And you can see all the result is actually in a very good shape, I would say. So next, of course, for any new technologies, there will be a lot of challenges because it's something new whereby if you don't have the spec, people will question, is it can be done, or how does it behave, especially plastic, whereby you use every day but you never thought of putting it inside this mix. And also in research wise, if you look at the if you search through the ResearchGate or even the internet also, not many info being or not many research being done. Okay, so you face a lot of challenges during this stage, especially this thing is actually done like 3 to 4 years ago. So now only you slowly can see all these plastic thing coming out, but most of it is still under the research phase, I would say. So of course, we have identified few challenges during the lake, of course. Okay, so the first one, of course, is the challenges in the premix plant. So one of the problem, actually same goes to most of the modified binder. So we need to maintain the temperature. So the temperature, because for any modified asphalt in the markets, you require higher mixing temperature compared to the standard modified bitumen. So the standard bitumen. So the standard bitumen is around temperature is about 160 during mix. So definitely for modified bitumen, it require higher. So you need to make sure before you even started the plant trial, you have to assess all the bitumen blending facility to make sure all the temperature can be maintained. And the premix plant as well, you have to check all this whether the aggregate able to heat up to the standard that you want, and also whether they can maintain the bitumen temperature inside their storage tank. This is also very crucial. Okay. So another one is actually on this the temperature drop during transferring bitumen to the patching plant, also causing one major issue during my plant trial. So because sometimes when you have this kind of some of the premix plant, I would say they have a bad experience of using modified bitumen, because when they transfer into their storage tank and they are unable to discharge out, so they have to heat up and discharge the one that trapped at below of the storage tank. So they sometimes they are kind of refuse to use this kind of the normal way of putting the bitumen inside the storage tank and transfer it up to the patching plant. So another way is actually direct transfer from the tank to the patching or the mixing chamber. So, but then you have to be careful on transferring all these bitumen, because for binder, for modified binder, is a very sensitive binder towards the temperature. So whenever he went down to a lower temperature, definitely there will be a blockage or clog inside your transfer pipe. So that one is actually will cause you a lot of issue, whereby you definitely need to like more than 10 hours to melt it and also to transfer it back. So of course, this one have to be predetermined during your what do you call it? Your trial lay, okay? So or your plant trial, you have to determine it and have to make sure everything in order before you start your job. So in short, I would like to say is actually you have to do your internal plant trial as early as possible before you have even wanted to put your lay on the actual road. Okay, so this is the thing that I've identified during my building plant. Next will be during the constructions. So the constructions in this what do you call it? The Jalan Lodging or Simpang Pulai Lodging. As you know that this is one of the coldest area in Malaysia. Okay, in Semenanjung. Sorry, someone talking.
Mr. Chia.
Hello.
Mr. Chia. Bang Ching, can you have to mute? Okay.
Okay. Mute. Okay. Thanks. Thanks, Dr. Zara. Okay. Yeah. The next one is actually during the road constructions. As you know that the this area is one of the, I would say one of the highest area in Cameron, because I need to travel 30 minutes from Tanah Rata to there. So and when you are getting, and the road getting there is actually going uphill, it's not going downhill. So it is make a lot of trouble to us. So okay. So first thing, of course, is the low temperature. We have been monitoring the temperature there for more than 2 months, 2-3 months, and we look at the temperature is always either it's low temperature or it's actually rain. So it's actually causing us a lot of problem, because you don't want to lay your road during its raining condition. So of course, this is one of the biggest challenge in our road construction. The next one is highly high humidity. And actually very close to the dew point temperature. What is the problem if let's say you have high humidity, which means that if whatever prime coat, tag coat that you put, it cannot be dry. Even though you use the rapid setting, which is the RS type of tag coat, also you need to wait for a few hours to dry, which is actually tremendously jeopardize all your laying work. So this is one of the problem that I'm facing during this what do you call it, the laying. The next one is of course long travel distance, because you hardly find a premix plant in Cameron Highland, to be frank. So the nearest one is actually in Kelantan or in Perak. So both of them also require about 3 to 4 hours to travel up, and especially if let's say during near to what do you call it, the public holiday, or even during the working hours, it's actually a lot of traffic there. So we face a lot of problem during this, because as I mentioned, temperature is one of the sensitive element in all premium mix, or even premium hotspot. So this challenge is how you're going to make sure it's able to maintain the right temperature when you are compacting. That is actually very, very crucial. So the next one, of course, is weather lah. So we cannot deny that the first trial that we have done is actually consecutively rain for 5-6 days. So unfortunately, the rain hit when we are laying, so we have no choice. We have to stop it because JKR is there. JKR also don't feel comfortable to proceed. Of course, this is the one of the major requirement that we cannot do. Requirement that no work to be conducted during rain. And you can see the whole day from morning 7 until at night about almost evening at 5 or so is actually blur. It's a heavy fog, if you can see. So, and even you can see someone is actually holding the umbrella. So you can see we cannot proceed. You cannot proceed for the then of course we need to find another day. Of course, you can see here we really going to find out which week or which day it can be late. And also the rest we leave it to the God. So to determine whether it can be rain, it will be rain or not. So and it's actually very fortunate and delay the time is clear. Clear. So the blending how we can actually overcome this is actually our blending technology to enable all these plastic and also our spot can maintain the temperature all the way from the premix plant up to the laying site. So, and also this is one of our one of the showcase or one of the challenges that we accept to try lay at the low temperature, so which is 16. Unfortunately, we can't test at an even lower temperature because we don't have. So this is the lowest temperature that we have. So we try it, and we want to challenge it. The bitumen, how does it behave within this kind of environment? So, and we are happy that we are able to overcome all this issue on this. I mean, on the temperature thing, because yeah, we can't lower that. We can't lower that. If I not mistaken, I think it's 140. I think not 140, 130 compaction temperature. So we have to maintain a higher temperature for compaction, or else when your roller rolling roll lower than that temperature, it will cause damage to the hotspot because the hotspot already hardened. Okay, it's very challenging. Next is the existing road conditions. Yeah, this one I would like to share to you on how serious is the road damage, and this is why we have decided to go for SMA. Not even 14, is actually 20, so that it can actually help to resist the higher load, because we see a lot of in fact we see a lot of the Balak truck passing by. Even when we are sitting there for discussion also, we see a lot already. So this is the defect that we have identified along the tri-lane. So you can see the cracks is common, patches is common, rutting also common. So delamination and raveling especially a lot. So because lack of maintenance. So this is, for me, it's kind of perfect place for me to test my a product, of course. Okay, next. So I'll show you some of the photo on how serious is the defect. Okay, so of course from here you can see a lot of crocodile crack, longitudinal crack, and also block crack. And you can look at the road. Is actually you will see a lot of wet spot. So that is actually another serious issue that we are facing, whereby there's actually underground water. Okay. So next you can see coagulation, depressions, rotting is everywhere. You just name it, you can find it. Okay. So after that, you have delamination because the patching is, I believe, is done by local and it's not properly done. That's why after that they have a delamination. And also you see bleeding, polishing, raveling is everywhere. After that, patches, because you can see they repatch, but at the end of the day, it comes back within months. Okay. After that, you can see the pothole, the age issue, and even the drop off also happened. So, and we have done some because of this issue. Okay, because of this issue, we are very worried that we will jeopardize our technology trial. There. So we done a pre-assessment on this road. So we have done core tests. Of course, definitely need to do. We need to find out what happened to the existing road, and you can see that it's actually lots of particles. You can see that this picture, the water erosions, and you can see polished aggregate. Then if you notice, this below one is actually AC28, and this is actually AC14, and two of them actually separated, which means that it's very highly eroded by the water. So definitely a lot of water attack there. And the second core sample that we have obtained, also you can see it's polished, lots of fine particles, which means the bitumen already came off, and a lot of water erosion. And you see a lot of water void, which is the honeycomb also, which is also related to the water issue. And actually we have a what do you call it? Interesting finding, whereby there's after we core that sample, and the hole and the core hole is keep on refilling with water. So the water is, I think, it will fill up to the surface area within 7 minutes, after 7 to 15 minutes. It depends on the timing lah. So it will feel pretty fast. So we definitely identify this is the main cause of the issue that all these things happen lah. So which means that they don't have a proper underground drainage for this stretch of pavement. So how we overcome this is actually we got no choice, because all this groundwater issue. If let's say you won't tackle it now, you definitely another separation in between the varying cost and also minor cost. So what we do is actually we mill. You got no choice. We have to mill until the final cost, and we after that we surface with the same thickness of the binder cost. Then after that only we proceed to the varying cost laying. Okay, so the road until now still under monitoring, and we see that after doing this, of course, after doing this, the water still, some of the portions still coming out. AC14 we don't have I don't have a high expectation on it, but SMA20 definitely we are actually monitoring it. So if you are interested to look at it, definitely it's most welcome, because before you even reach there, you will see a signboard saying that it's actually a tri-site. So okay, so next you can see the conclusions of this laying is that the aggregate, of course, we need to be tested before we do a trial. It's actually compliant to JKR spec. And the plastic modified bitumen is able to achieve a binder of grade of PG76, which is also fulfill the JKR requirement. And the design mix of the SMA spec, the design SMA is able to achieve the JKR spec and further substantiate from the data tested tests that have been carried out by the quarry and also test lab. Okay, so the overall binder, I would say, show enhancement for SMA20 and also observe beyond the satisfactory. And also the potential, the plastic modified bitumen technology has shown a great potential to be used in road surface and construction. So yeah, so this is the overall plastic modified bitumen's materials or product presentations that you can see from laying until testing and until the end result. And yeah, this is I think this is my presentation for today. Yeah. Okay, now you can actually start to ask any question if you have.
Very much for sharing an interesting topic, because now we can see so many plastic outside, how we recycle. That's the new, like something we reduce about the waste, everything now. Okay, now if anyone has any question, you can ask directly, because we use the the Zoom. And or write in the chat box. Any question from the participant?
Why are the big difference in between the stability result for quarry and okay? I think there's a question from Muhammad Alif.
Question.
Yeah.
Okay.
Yeah. So I think it's a direct message. That's why you cannot see. Okay.
Oh yeah, I
So
cannot
yeah.
see it.
It's okay. It's okay. Let me read out. Why there's a big difference in between your stability results and from the queries and also lab. You have to know that there's actually two types of lab in actually three types. I would say three types. So there's actually query lab, basically for quality control purposes. And another one is actually the test lab, which is the certified test lab that you can get. One of it is actually that you know, which is the what they call it, some like ICRAM, okay, or even JKR Creek. They have a very good lab. And after that, the next one is actually the university lab. So all these lab, they have different people to conduct and different way of maintaining their machine. So you have to really look at, if let's really look at the purpose of your testing. If let's say you are for quality purposes, the most likely you are going to do because do it to show that your result is able to achieve the JKR spec, then query is sufficient for you to submit. But if let's say you are going to do the real test for whatever you have done, especially for this kind of new material, definitely you need to go for a better lab, or fully equipped. That they have their personal or even the supervisor, which is qualified certified test people to do it and look at your result. And if let's say anything suspicious or not right, or even not following the spec, or they will redo again. So therefore, you can see a lot of result from, although it's the same material. And to be frank, just for your information, it's actually the same material but different result. It mainly depends on where you test. So yeah, so you have to take note of that when you are doing some new technology. I hope I answer you. Okay, so then that's the next one. I have a questions from Mr. Ganaseharan Mulyandi. Okay, to everyone. Do you consider plastic as an addictive or as one of the main component? Yes, actually, these questions actually being asked a lot because plastic, a lot of time plastic we consider as addictive because but for this plastic modified bitumen is actually a main component because we modified the property of the bitumen. So addictive, it may be like maybe you can change some of the property, but for okay, but some one of the main component, because you use the plastic is actually melt inside the bitumen. I just wanted to share with you because this one a lot of people asking the same questions, whereby there is actually a wet mix and also dry mix. If you look at some of the extensive research, they have also mentioned of it. So wet mix means you mix the plastic into the bitumen, you blend it. That one we call wet mix. Dry mix means you blend the bitumen, original standard bitumen with aggregate and also plastic. Then we call dry mix. So when the main difference of these two kind of mix is that the wet mix can give you a more consistent result because you monitor it and you will be looking at the result before you send it to the plant. Premix plant. Whereas for dry mix, you got no chance to look at the performance. The only thing you can do is actually you grab it and you do the low sample test, which is all the see whether the test is complying to the JK aspect or not. For that, you can be saying it's addictive, or you just simply dump the plastic into the root as a root material. So I hope I answer you these questions. I saw hold on. Okay, so some other question coming in. I see Mr. Calvin. So Mr. Calvin said, please do a trial run in Sabah. Yes, of course. If you have a chance, of course. Because
Petronas
but
can go there.
but yeah, to be frank, Sabah is a very challenging place, to be frank, because their aggregate property. So we have to tailor make it to suit to the local condition. This is what we are doing also. Because we try to use as much as local material. We don't want to import something which is not that area. So it's actually to help the community as well. So of course, we will more than happy to do that. Okay, so Mr. Lau asked about the does the root material erode and pollute the surrounding area? Okay, the root material eroded. Okay, I'm talking about this. I presume you're asking about the bearing cost that I mentioned just now. So when I say the plastic modified bitumen means it's actually the plastic already melt into the bitumen and chemically form part of the bitumen. So when you say eroded, it's actually erosions of bitumen. Okay, so I presume you're asking that. So it's actually same goes to the normal standard bitumen. It won't have any difference in terms of whether the plastic will pollute the environment or not. So at the end of the day, we are just talking about bitumen. Okay, just that this modified bitumen. Okay. So next, see. Is it suitable? Okay, next is actually Encik Muhammad Alif again. Is it suitable for mixed design with SE recent okay, these are all only SMA. So you're asking about whether the plastic modified bitumen are able to suit all kind of design mix or not. Yes, it's suitable because if you can see inside the spec, you're talking about SMA, talking about porous asphalt, AC14 premium mix, which is the AC14 plus polymer modified bitumen. And even if you ask about FMA, the fiber mastic asphalt also, PMB can work with all. Because bitumen is actually a bitumen. So the purpose of we want to enhance the bitumen so that it have a better properties to make it more adhesion, I mentioned just now. Okay, so that it can last longer to hold all the aggregate together. So it is able to mix with every design mix, I would say. So the next one is actually Mr. Ganesaharan Munyandi. Do you do the skid resistance test? Yes, of course we do it because this is part of the our monitoring program, whereby we are going to take it every and now currently we are doing every month. Okay, so the skid resistance, of course, you're not only skid resistance, we are doing the road scanning and also the grip test. The first result that we have obtained is all within the specifications. So I'm so sorry I'm able to update the site right now because it's still in a draft result. But I can tell you, all the skid resistance is actually able to achieve. So okay, okay. The next one, Dr. Ng, say if you have a waste tire that place plastic, why? What would your immediate comment be? Oh, if you use waste tire. Oh, okay, okay. So this one, in fact, this question also I get a lot. Actually, waste tire is a crumb rubber, or we call it rubberized lah. So I won't comment much on this because I will focus on plastic. But I will just say that both of this material, I also go through a lot with this waste tire. Both can achieve PG76. If you are looking for a premium asphalt, both can achieve, and they are also considered as a green product. So that's just that when you are looking at waste tire, you have to look into more detail whether it's a natural rubber or synthetic rubber lah. So that one will affect the bitumen behavior or properties. So yeah, but for plastic wise, you can actually mix all this plastic, no problem. Yeah. Okay, I hope I answer your questions. Okay. Do you have I think so far this is the message that I get. Any more questions?
Yeah, that's about regarding the certificate. Is it?
Yeah.
How the secretariat Sue, is it required any email or you just can pick from the chat box?
For certificate ke Dr. Zara?
Sebab ada request yang certificate.
Certificate tu boleh email to ACT for request.
Oh, okay.
Since we use Zoom platform not provide the certificate so far.
Okay, so everyone who wants the certificate need to reply the email, eh?
Yes.
Okay.
Email to ACT request for the certificate. So
another question. Okay, that's suppose Another more question?
Yeah. I see Mr. Calvin is asking a questions. It would be better if you can overcome the challenges because the interior of the Sabah is always low temperature, high humidity, and always rain. Yes. we noted. That's why this is the trial that we have actually give us a lot of trouble and also give us a lot of chances to engineer it in a way that to overcome these challenges. Of course, these challenges will be shared with you if let's say we are going to try it at Sabah. Hopefully it can be done as well. Okay. So the next question is actually Muhammad Amin. Is it possible to use PNB for highway instead of federal road or state road? Oh yes, of course. In fact, if you notice that there's no difference in between federal roads and also highway when it comes to road lah. So of course you will see LM or even plus highway, they have a better spec or even more not better spec, I would say more stringent spec. So at the end of the day, you come back and you look at it, it's actually they are using 60, 70 most of it, and AC14 forest hotspot, SMA. All of this is actually we are because we are talking about the mixed design, the material that we use. So it will not have any big differences in terms of whether it's federal road or state road or also highway lah. At the end of the day, they are still following either LM spec or also JKR spec. Okay. So the next one is so Dr. Ng. So looking at the encouraging trials or pilot result, what would be the unfolding expecting from JKR period to commercialize in Malaysia? What will be the unfolding expectation from JKR period? Thanks for okay. Thank you so much. Okay. JKR, of course, when it comes to any material, they talk about cost lah. This is the only thing they're looking at, yeah, when talk about cost, of course, we won't be too because if you see most of the modified bitumen that you have that you know in the market, latex, Kaplan, chrome rubber, SBS, now plastic, okay. All this thing is of course why we call modified bitumen, because we modify it. It's becoming the normal one is 60-70, so you modify it become of course you modify, of course you want it to be better. So all the modification require cost. So like burning costs, electricity, manpower. So no matter how, all the modified bitumen will be more expensive than 60-70 or standard bitumen. But what we are coming in is we are compared to the premium mix or premium asphalt. I can only tell you the price is very competitive because you just look at the original materials of the additional material, compare, then roughly you will know roughly where we are. I would say that. Yeah. Okay. Thanks. Are you promoting? Okay. Next one is actually Engineer Wong, Wong Chun Tek, asking about whether promoting PNB into the PAM Colonial project. If we have a chance, yes, of course. Yes, of course. Because I learned that from Sabah, there are a lot of problem in terms of course, bitumen is one thing lah, because they don't have bitumen, so everything is imported. The next thing is actually the mixed design. So this is where we have spoken to JKR Sabah as well in this problem, and yes, we are looking forward. Yeah. So on the whether can share presentations, I'm so sorry I cannot share with you right now because this thing is still although the result is promising everything, we still need to get because it's a collaboration with GKR. So of course we need to get everything done before we share, because in fact in later stage the spec is coming out. So by that time you're more than welcome to look at the spec, because most likely all the information will be there as well. Okay. So we can look into, okay, the next one is actually Mr. Muhammad Zaharuddin. Okay, sorry. Okay, this is actually from
I think from your department.
yeah, correct. Yeah, Zaharuddin, my colleague. It's also the head of this ASPAT innovation team. So yeah.
Oh, Cik Zaha, you want to, maybe you also want to talk something? Okay, I think another question, Mr. Pon, engineer.
Yes, okay, correct. So yeah, Mr. Ganesaharan, yeah, we are talking about I appreciate you can look into the producing SMA in drum mix plant during this collaboration. Yeah, because you're right. The currently the mixing the premix plant that we are looking at is actually only at patching plant because they produce a better result and more in a more controlled manner, I would say. That's why in all trial state, as much as possible, we'll use the batching plant. So instead of drum mix plant, of course, I found out there's actually another problem if you go to a further area, which is like Sabah, Sarawak, it's very hard to find batching plant. So that is actually a challenge to us to use the drum mix. Yes, definitely we'll come to that. But whether it can be SMA, that one we have to further collaborate with the local talents. Okay, that one. Yeah, any more questions on that? Yeah. Okay, do you make sure the waste, okay, Encik Muhammad Alif, so he asked about how do you make sure that the waste plastic melt homogeneously with the pigment? Yes, actually, this is a very, yes, good questions on the bitumen because what we want is to achieve the homogeneous bitumen so that we wouldn't have any some particle is not being melt properly, so actually still floating, it's not melt yet. So actually, there's actually one very direct method, I would say. It's very easy. You just use a steel stick, put inside a tank and take it out, and you see is there any particle stick on the stick or not. That is actually a very direct testing. Of course, you need to extract out and do all this testing to make sure that the bitumen is able to achieve the required viscosities and the specifications. Then we know that the bitumen is able to mix, is already, the modified bitumen already homogeneous. Yeah. So yeah. Any more questions?
Any more question? You said because today engineer Pon what's it give their like sharing to us about the new innovation from Petronas. I think it's word to SDG, is it, Mr. Pon?
Yeah, correct. So we as I would say a leading company in Malaysia, we need to play our role to ensure that whatever the not even Malaysia, is actually globally, the sustainable agenda, we need to meet that because we can see a lot of people say, yeah, Petronas doing oil and gas. So you yourself starting already spoil the environment. But if you look at it, there's no argument on that. But then what we're trying to do is actually we produce that much, but we need to reduce that much as well. This is what we have committed to the to ourselves, not only ourselves, to our Malaysia government and as well as the Paris Agreement that Malaysia have signed. We need to do that. That's why in our agenda, we have to always mention to ourselves net zero carbon emission, which means that we produce that much, we have to reduce that much. Which means when we are doing plastic modified bitumen, because if you are using virgin plastic, the whole process from oil, okay, up until you get the virgin plastic, the whole process is actually emission a ton of carbon emitted. So what we're doing is actually we use the plastic, waste plastic or used plastic and recycle and do. We have already saved all the processes from oil-based up to the plastic stage. So we aim on top of that, we are actually replacing part of the bitumen because let's say you are 100% bitumen, then after that, when you add in the plastic, So the plastic is actually going to replace part of the bitumen, and this is where we are able to reduce the carbon footprint or carbon emission. So this is also part of our task actually, to calculate the carbon credits or the carbon that we have saved in this product. Yeah. So we definitely adhere to whatever SDG value established in Malaysia.
So any question?
Mhm.
Now the time is 6:30.
Mhm.
I
Yeah.
think.
Okay. Don't worry, you can ask any question. If I can answer, I will answer. Of course not. Yeah.
If you can ask directly, also can unmute if you want. If not, can write in the chat box.
Yes.
So nak ambil gambar picture tak Su? Sekretariat.
Boleh saja kalau nak ambil gambar.
It can. There's a good idea actually. Idea yang sangat baik.
Actually, it's good because the speakers provide the time for us to share about the new knowledge. Something is important because sometimes we heard from overseas, but the local company also they do the innovation. Something is good because Mr. Pun before this in the Malaysia Road Conference, I heard from the Shell. They talk about the innovation about the new premix, the new bitumen product. I think from this presentation, I can see that Malaysia also have the innovation for the bitumen.
Yeah, of course. Yes, of course. We are serious about bitumen. Yeah.
Cik Zaha. Silent, Cik Zaha.
Hello, Assalamualaikum.
Waalaikumsalam, Cik Zaha.
Good afternoon. Sorry. I was in the meeting just now. Just finished the leadership meeting. So I just joined half an hour.
So anything you want to share to the participant? The good news or what what's it for the future, something maybe?
Okay, actually, thank you so much to Dr. Zarvizan for hosting this webinar, and also the IEM, and also all the participants joined the webinar today. On behalf of Petronas, we really happy for this kind of conversation and webinar. We are looking forward to have another session after this. So a lot of things that we can share. It's not only about the plastic bitumen. We have a lot of innovation in the pipeline that we want to share with all the local people, especially from JKR and the authority here, right? So again, I think from our management is actually, as mentioned by Mr. Pun just now, we are looking into the innovation. We are really patient and really seriously looking into the innovation and sustainability agenda to support the Malaysian sustainability agenda and also the global. And the carbon footprint is our main target or KPI to achieve this year lah. We are contribute to that. We are really contribute to that. And in terms of supporting the government, I think all the innovation, all the new product is actually, I think we are looking closely. It's not about JKR only. We have a lot other minister and kementerian that we are looking for so far with the MOU and also a few other agreement, especially on the innovation and the new products. So I think with this webinar, we really hope that support from you guys, and also we are happy to share any other next session with you guys. And we hope that we together as a Malaysian, we support this one of the product for the better route in Malaysia lah. That is our intention for the PMD. Because we want to share, it's not about the commercial whole, but it's actually the idea, the innovation, and the solution. There's something that we can do better for our nation. That is our target. And we hope that the aspiration we can share with all of you today. Okay, thank you.
Thank you.
Okay, thank you.
Thank you, Zaha.
I have another question from Dr. Ng.
Yeah, I saw that question. So let me read out. How are the cut plastic dry up material to mixing into the bitumen? Okay, so okay, during just to share with you the when we mix the plastic bitumen, mix the plastic into the bitumen, you can straight away identify whether the plastic is dry or wet or moisture, I would say. So of course there's a procedure when the plastic come in. What you need to do is actually you need to put in your hand and just test, because what we want is actually that we don't take the plastic and go and do some sort of test and test the moisture content, all these things. No, it's not required. As long as when you touch it and you hold it, it's actually you don't feel your hand is wet. That's it. Another indicator that you can see, but when you are mixing that time, you will see a lot of what do you call it? This gas, or not gas, what do you call it? The what do you call it? Yeah. This kind of thing indicate that, and a lot of water actually coming up when you're mixing that time. When you open up the mixing manhole, the mixing tank manhole, you see a lot of water coming out. Then that's indicate that your plastic is actually very moist or already mixed with water. Perhaps maybe your storage issue, or maybe before they reach, the plastic already water already penetrate inside the thing, the plastic. So when you are doing the mixing, you will tell all the behaviors or all the thing that you see will tell you whether the plastic is dry or not. Yeah. Okay. I hope I answer your questions. Thanks.
So
Yeah.
now we are 6:30. I think.
Yeah.
So maybe we can stop here.
Yep.
In the next session, like Mr. Zaha mentioned, maybe they have another session. Maybe we can do like workshop, maybe. Okay.
Yeah.
Okay.
Okay.
Okay. Thank you again to IR Pun for your time and valuable contribution for today. Very knowledge. I think the participant got so many information, so many knowledge for today. So I think I'm on behalf of the Highway Transportation Engineering Technical Division group. I would like to thank to all of you again to your active participation in this webinar. I hope you gain knowledge from this session. Thank you and have a nice day. Thank you very much, everybody. Also the speaker for today. Thank you very much. Thank you very much.
Thank you.
Okay. Bye.
Okay. Bye.